Question 10 gets a little bit tricky, and in fact there are several different ways to do this, but let's just examine this for a minute. What we're trying to prove is that BAC is congruent to EAD. And I know that we have a situation where they both are kind of bordering CAD. So what I'm thinking is that we're going to have to use a subtraction property. Why? Because that's the subject of this textbook. So out of the many, many, many directions I could go in, I'm thinking we're going to need to start with two congruent angles. Looking up at what we know we have a right angle, BAD, and then we know we have perpendicular lines. And I'm going to take care of these perpendicular lines because the only tool we have about perpendicular lines right now is the definition. And we know that the definition of perpendicular lines is that they meet to form right angles. So here we have I know that angle CAE is also a right angle. And out of all the things we could say about right angles, we could say they equal 90 degrees. We could say we have complementary angles. We could, but I am going to start with the fact that we know that these are going to be congruent. So I'm just going to say angle BAD is congruent to angle CAE. And I'm going to use that first theorem that we ever proved, any two right angles are congruent. And here's why. Because now I'm to the point where I can use the subtraction property. This angle is congruent to this one. And I also know that each of those big angles that I outlined in green share angle CAD. So if I just got rid of angle CAD from each one, I'd be left with BAC and over here EAD. So this ends up, I kind of left a lot of space, but it turns out I didn't need to. I can conclude what I have in question 4 by the subtraction property. And yes, there are other good ways that you could do this. In fact, I'll show you another one. Here's another direction we could have gone in, and this would have been fine. This would have been fine. You have another property that says if two angles form a right angle, then they must be complementary. So here's another good direction. You could have said angle BAC is complementary to angle CAD, and angle EAD is complementary to angle CAD, and that's that theorem. If two angles form a right angle, they are complementary, and then we can use the complement theorem because those are the same angles. So here we have two angles that are complementary to the same angle. So I could also say angle BAC is congruent to angle EAD, and in that case I'm using the complement theorem. And this one is really just as good as my first one because there are only 4 steps. So either one of those for number 10 would be great.